All right, so hello to this is week 9, I believe. Yeah, it should be week 9. Let me go ahead and share my screen. Um, okay, so share entire screen. All right. So this is uh, week. I should check. Well, first I should talk about the announcement. I do apologize for not being able to record that extra video to go over assignment 4. It was a bit complicated. There's so many parts that, we had to go through. Though the criminal intent was there, it's still, it was still a lot of new concepts, new things that we had to figure out, such as the adapter, the holder, and though we talked about it last week, I wanted to give you a better demonstration of what to expect or what I expect for assignment 4. So I will, after I go through the announcements, after I go a little bit through what we're covering today, I'm going to go ahead and jump straight into assignment 4. So it's at the beginning of the recording, and then after that, we're going to go to the lecture. The lecture is a little bit long today. I do apologize about that, but it is coroutines. And with that, we're going to be able to use databases. So let's get started. So for this was week 8. Assignment 4 has been extended to October 24th, which is this Friday. And again, because of that, this week we're going to go ahead and cover week 9. And week 9 deals with coroutines and database, as in part 1. And so we're going to cover part 2 next week, and this should be enough for you to get assignment 5 done. Okay, so and then so the oops, this should be hidden from you guys. So let me hit that right now. So there's the lecture slides, then there's the week 9 discussions. I am really behind on discussions, so I do apologize again about that. But as long as you get it done before I go check on them, I'm not taking any points off. So if you forgot to do one, I know it wasn't showing up correctly on some of the dates. So go ahead and get it done. I'm not taking points off for late discussions until I grade it. So if after I grade it and you still want to submit, then I will be taking points off. All right. So assignment 5 is a database and glucose level monitor. There is a small database file. So you do need this to get assignment 5 done. So please make sure to download this and include it in the database. In your application files. There you go. And also there's criminal intent 12. That's chapter 12 of the Android Big Nerd Ranch book. Okay, so you should have everything you need for assignment 5. So something, please, I will announce this again and again. I'm still getting submissions that don't have the video. The video really helps me in the sense that at first I get to see that it's truly running on your end. So you get half of the points already if you could show that it's running on your end, right? And so because sometimes when you upload the files, they don't upload correctly, and when I'm downloading them, I can't see anything. So that gives you obviously half of the points already, but then it allows me to just run through the code pretty quickly without having to load up a lot of libraries. It takes me about an hour and a half to get one grade done, versus if I have the video, I could just go through the code easily, faster grading. Okay, but I still do go through the code, just so you know. Okay. All right, so let's, as I mentioned, right, first thing first, I'm going to go ahead and cover Android Studio. Oops, sorry, let's see, wrong screen. Okay, there you go, it's on the other one. Okay, so I'm going to cover, let me go ahead and close this one. I'm going to go ahead and cover the assignment 4. Okay, there's a lot of moving parts. There's a lot of things. You probably had to deal with a view model didn't exist, right? Or this other library doesn't exist and I can't import it. Well, it has to do with the dependencies and the Gradle. So I'm going to focus on that towards the beginning because that's probably most of everybody's issues if you have any. But we'll get that done, and I'll show you how to get this. I mentioned it, but I didn't show you last time, so I will show you right now. Okay. So first of all, there are a few files in the Gradle. there's this file called the TOML file. And then this TOML file, you get to go ahead and determine or add the libraries, the plugins, and the versions that you want your application to run. So what did we need for assignment 4? For assignment 4, we needed this module right here, or two modules, right? The view model, which was already there, and the fragment as well. And so if you don't have them there, you probably weren't running correctly, or your file wasn't running correctly. So how do I get this? Okay, well, sometimes when you import a view model class, it will automatically do that. Or if you did it through the fragment importation here when you were creating your file into new and then fragment, more than likely it created it for you. Sometimes it doesn't. Okay, so before it never did, but right now with the newest versions it does. So I will get to it right now. So how do we determine this code? Well, first we have whatever we want to call this. In this case, in Android, this one, Android X fragment. Then we set it equal to, and we call it the module name. So where do I get these module names? Let me see. I have so many things open. Okay, here. Okay, so here, developer.android.com. You go in here, you search in fragment, create a new fragment, right? And then in here, you go into the version number, so you understand what version number Android Studio is running, or Android itself Android developers are running right now. Now this changes semester to semester because, and even a couple times during the semester, that is because this is a live environment, a developer live environment, so we have to go with it. But this is good practice. In real world, this is what you're going to have to do, right? So in here, we get the version, and then we get this right here. So Android X fragment. And then from here, we get to determine the version number. So the version number is here. So I got this. Where'd it go? Right here. Let me modify this so it's not there. Okay. So in here, so I got Android X dot fragment fragment dash KTX. I think that's dash KTX. So this one, because it's sorry, this is Java implementation. This is a Kotlin implementation. So that's the one I'm gonna get. And then from here, what I do in this TOML file, I said comma, and then I said just calling the version number that we want. Well, there's this thing right here called versions, and in here I have supply the TOML file with the versions of the different components, libraries, plugins that I want. In this case, I have a fragment 1.8.9. So that's from here, fragment 1.8.9. Now, can you name this whatever you want? Yes, you can. I could have named it fragment, underscore version instead of fragment KTX. I just decided to put a KTX to make sure that it stands for Kotlin. You name it something else, you can. That's fine, but just make sure to call it whatever you decided to call it right here. Okay, so that's in the TOML file. So libraries in here, the versions, you determine the versions, and then the libraries, you go ahead and set it up. And so for this one, I set it up in a module. Okay, so this is a module. And again, these are things that you can find right here. Let me see where it says, I found it in here. For Android, it's a whole module that it has different components, and we'll talk, or I should have, yeah, we'll talk about it later on, but right here we have a module. The other thing that we have right here is, and this one you will need for your assignment 5. So if you have this, you could just copy this directly. It's totally fine, but you will need the room and runtime, Kotlin, and compiler forms for your database. And again, I just looked it up. Room version is 8.2, the latest one. So let me see. Room version 8.2. Okay, and I just pulled in all of them for the things that I need. Now, that's for here, for the libraries. Now, for the plugins. In the plugins, we need the JetBrains Kotlin Android, and this one probably already came with it, but if it doesn't, you do need it because some of the libraries do require this plugin to work. The other one that we need, and this one is required for you to run your database, and that's the Android X dash KSP. KSP stands for Kotlin. Let me see, what does it stand for? I just know what it works, but I don't know what it stands for. Okay. So this is pretty much to be able to render that database. KSP stands for, let me see, it's a new one. The Kotlin symbol processing. So before there was a Kotlin annotation processing tool, and this one was very, very slow. So they moved on to the KSP, which is 2 times as faster. And this, again, we do need it for that room library that we are gonna be using. And you might be wondering, what is room? We will talk about it today. Okay, so, but that's for the database, what we use for the database. But anyways, you can find more information on how to do these things in Android Developer. So here's another example. This is the version that or the Kotlin, sorry. This is the version that I got. As you can see here, we have it, I have it right here. Okay, so that's for the KSP. All right, so these are the things that you need. Give me a moment, please. Okay, all right, so once. Okay. All right. Sorry about that. All right. So then, so that's what we need for this TOML file. Now that we've looked at the TOML file, let me talk a little bit about the build.gradle Kotlin file. Okay. So in this build, we've talked about this file before, but I've only told you about the build features. I think that was the only thing, and there was something else. Oh, and the dependencies. Okay. Well, I want to talk now about the plugins. So these files are connected with this TOML file, and the TOML file is a version catalog library. And this one is for the Gradle files for the app itself. So we're going to have to go ahead and add this alias. It's inside of the libs plugins in androidx.ksp. So if you don't do this until you finish your TOML file, and after you do your TOML file, it's going to ask you if you want to compile it because there are Gradle changes. Go ahead and click on yes, like there's changes, so compile it, and then you can then import it here, and it's going to actually show up for you, so you don't have to remember everything. So as you type in, so for example, I'm going to comment this out so you can see it, how it's going to show up. Okay, so, and then the bottom, yeah, bottom is fine. Okay, so I could do alias, and then here libs, and then plugins dot androidx, and then as you do this, it's going to give you options to fill in for you. Okay, now if it doesn't give options to fill in like that, it's probably because you forgot to synchronize. Okay, so sync now so that it shows up for you. Okay, and then so that's what a plugin that you have to add. And then finally here on the dependencies, right? For this coming up, so we don't need these. These are redundant right here. Okay. All right. So for these, again, dependencies, you're going to be doing the implementation. You're going to call in the fragment. This might be an issue right now in assignment 4 if it's not working for you. That fragment is probably missing. Then we have the Android room runtime KTX. These three are going to be part of assignment 5. Okay. All right. The recycler view is another thing that you might be missing in your assignment 4 that you do need for assignment 4 to work, as well as this lifecycle view model. Okay. Without these two, you probably are running into a lot of issues where it's not finding view model. It's not finding things like that. Okay, so let me go back to this TOML file and I'll show you where we have that. So lifecycle view model and recycler view. These are the two things that have also imported here, manually did it. Okay, so these are the two that I have there. And again, where do we get these? We get these from Android. The versions, these things we do get from Android Developer Studio. And I'm just going to go ahead and sync it now because I did modify this dependencies because it was redundant. Okay, so, all right. Any questions? Okay, all right, so no questions. Now, let's go through assignment 4. Okay, assignment 4 has a few files. The first one is this glucose, right? What's inside of this glucose? Remember, this is the data class. This is your module, which you get to decide, or like you get to decide what is going to be inputted in your entry, data entry, the information that's going to be held for this glucose class. So in here, I have the ID, I have a date, I have fasting, breakfast, lunch, and dinner. Now, in my previous code, I had an integer int -1, right? If you were following my code and, like in the next classes that I'm going to show you, in the next, not the data class, in the next code that I'm going to show you, if it's giving you an error, it's because of this integer. Okay, so make sure that it is, with the next code, I modified it so it's no longer like an int. I think it was a -1, something like this. Okay, because then it's going to change things. All right, so that's my data class glucose. Now, in my glucose adapter, I talked about the holder and I talked about the adapter. I did not create a holder class on its own. I decided to do it both in one because, they work hand in hand, they work together, and I kind of wanted to keep them together. However, you can create two different files, create the glucose adapter and the glucose holder separate files, Kotlin, if you want to separate things. Totally fine. You can go ahead and do that. For me, I'm not. I'm just going to keep it here. Okay. So what I've done here is, and again, why we don't use, or why we had to use the int question mark is so that I can have null variables. If you don't, then it's not going to let you do a null. You have to do pretty much a 0. Okay, so that's why int question mark, so you can have the null. All right, so from here, I have my glucose holder. I have the list item glucose binding, so that's from this right here, right? So I'm calling the values from here from my list. Remember what the holder did? The holder just pretty much hold the information for you for when the adapter called it in. So the adapter is the one responsible for pulling in each one of the views. Says, hey, I need the glucose, and this is the information that I'm needing for you. But the holder is the one actually, having that information that you need for each one of the individuals or each one of the entries. Okay, so that's here, and all you had to do was also, like every time you are or setting it equal to null for each one of them as you entered the information. And the adapter was, again, cover adapter back there, but it's just a list of glucoses that you're calling in, and you're pretty much calling in that the glucose holder. Okay, so in here, the glucose holder, to be able to pull in the information. Holds the information, the folder holds the information, the adapter tells you what you need. Okay. All right, so the next thing is the glucose entry fragment, and what did I do? Okay, I probably modified, I modified something in my previous code. That's okay. So in here, the entry fragment, what do we need? Well, it's a fragment, and this fragment is pretty much pulling each one of the entries that we modify. So this is going to be, what you're going to be calling in, looking at all the levels, editing those levels. And in here we have first the binding, right, for checking checking abnormal readings for abnormal, checking for abnormal fasting, and then abnormal itself, and then getting the status, right? So if it's in fasting mode and the reading is less than 70, then it's considered hypoglycemic. Else, if it's less than 100, it's normal, and anything, or sorry, yeah, if it's less than 100 is normal for, this is for, okay, for fasting, just for fasting. Okay, so in here, else, if fasting and reading is greater than 140, or it's less than 140, then it's normal. Everything else is considered abnormal. So that's pretty much getting the status, right, for everything, and everything else is pretty much anything bigger than that is abnormal. Okay, and so then here's again the logic. I did a do on text change, so that means that every time I'm modifying this information, I am getting the new result right away. Okay, so that's what this do on text change does, and I'll show you how that is working. So for example, if I have here, let's see, I have a 75. it says it's normal. Let's see if I put a 65, that should be hypoglycemic, right? And it's in red. So here 70, I can have 123 here, 134, and then let's say 255. Okay, so it gives you all of them, and every time you do change it, it's gonna give you a reading. Okay, so that's what the undo text on text change does. Okay, so there we go. And then and also the clear button. So I can go ahead and clear this, the whole thing. Okay, so now going into the list fragment. So this list fragment, you're pretty much calling in this view model, and in this view model, you're doing everything pretty much, and then you're calling in the recycler view. So this recycler view is part of this the glucose history in here. And then the view model, remember the view model holds your data, so in case there's any screen rotations, the data is still going to be there. So this is should be basic, something that we've done before. The only trouble that you might have would be, with the types, so the unit type, so make sure it's an int, question mark, or to make sure it doesn't give you errors there. And then finally, the main activity doesn't change. You're pretty much just calling the activity main. Now, before I had something called the navigation bar. Ignore that. The navigation, we will cover it in a future assignment. I think it's assignment 6, yeah, or 7, I can't remember. But assignment 6 or 7, we're going to cover the navigation module. And this navigation is going to allow us to change between screens, many screens, okay? But for right now, ignore that. If you saw it, ignore it. I did get some emails about that. I apologize about that, okay? All right. So then looking into the activity main XML file, I am just calling in the fragment. So I'm saying I'm calling in the fragment, and what fragment am I calling? I'm calling the glucose entry fragment. Now, when I'm checking your code, right, all I have to do is change this and look at your history list. And then from there, I'm able to see the list that you generated randomly. And that's for the future module. But in here, all you have to do is change whatever fragment you want to be displayed on your main menu. So that's how I'm able to see if you did your history or not, just by changing that. And if you want to try it out, you can. All you have to do is change it to, in my case, it would be glucose list fragment. Okay, so that's just for me, but for you, I mean, it might be different for you. I'm gonna leave that how it was. And that determines what display is gonna show up. All right, so the entry, my glucose entry, this is where I'm actually putting my stuff, where I get to do the entry for the glucose. The list, again, this is just a recycler view. If you had the navigation bar, remove it. I had that, but you don't need it. We'll talk about it in a future assignment, not for now. Okay, that's all you need for your recycler view. And then your list item, again, this is what's gonna look in your history. So when you run this, your history, what's it gonna look? It's gonna have 3 things in there. Okay, so let me see if I could show it to you. So this is how it's gonna be displayed. You're gonna have the date, the average glucose, and a check mark, a checkbox. And this will be checked if it's normal and unchecked if it's abnormal. Or you could do an abnormal check, up to you, okay? But you should have this during this module. And again, I'm going to be checking for these things when I grade. All right, so, and then the rest, should be the same, where you have your strings, your colors, your dimensions. You get to, we've worked with this enough that you should be able to, figure that one out. Okay, any questions? Yeah, so hopefully this answers questions. This fixes some code that we might be struggling with. There's a question here. All right, awesome. Okay, awesome. So I will continue then with the next item here, which is the class lecture. And if we find it, let me see, where'd it go? Second. All right, so the class lecture is this. As I mentioned, it is chapter 12 of the Android Uh, see the slideshow. It is chapter 12 of the coroutines and databases, APV, or yeah, chapter 12 of the uh, Big Nerd Ranch Android book. Okay. So the goals here is to create and maintain a local SQLite database to maintain crime data, perform asynchronous operations to allow multiple tasks to run simultaneously. So how does it translate to us in assignment 5? We're going to have to create a database to hold our glucose data. Same thing, again, if you're following this, there's not a lot of things that you have to change if you're following the book or the code in the book. So let's talk a little bit about asynchronous code in Android. And asynchronous code, so what does it mean, right? So there's something called a thread, and this thread is a single sequence of executions. What that means is that pretty much, like if you were executing instructions such as, go ahead and perform this action, well, there's a bunch of instructions that you have to follow for the action to get done. So for this could be go ahead and, I don't know, do some calculation. Well, you have to go through maybe doing some computations, some things, but the thread is pretty much all the instructions that you have to go to execute or to do whatever you need to do. Okay, so an individual thread can only do so much work in a period of time. So to keep the system responsive, the user, while also performing complicated tasks, developers distribute the work across many threads so that they can work simultaneously. So in here, the main thread is the one that the user interfaces with. And this main thread is pretty much in charge of making sure that something is getting done. Well, with Android, we want to make sure that we have multiple threads so that there are multiple things or multiple threads working on simultaneous things at once, okay? Or multiple things at once. So the primary thread, thread that manages the work the user interacts with directly in a small thread or the UI thread. So then we have the application threads, and each Android app starts with a main thread. Okay, so this is the main one, and this main thread is the one that the user really gets to interact, the user interface thread. And it sits in an infinite loop and waits for events initiated by the user or the system. So they're just waiting, like in a circle, waiting. And so the main thread can display the list on a view, in this case, a recycler view. To this, think of like the main activity, what the main activity is doing. Then it executes code in response to those events as they occur, and the main thread runs all the code that updates the user interface and maintains. They're sometimes called the UI thread. So here, this is how it looks. We have, this is a thread, you run some code and then it's done. Versus the main thread. The main thread is pretty much running at all times, and it's running. And then an Android or user might trigger an event, and the main thread is to process that event and then continue to what it was doing before or a new task after. Okay, so this is a normal thread, but this is the main thread. Just goes in a loop. So an application not responding, or an ANR, that's what it's ANR stands for, when it crashes, right? It occurs when Android's watchdog determines that the main thread has failed to respond to an important event. So 2 rules to consider when adding background threads. That is, so first we have the main thread that runs in the front, the user interacts, and then there's the background threads. These are the ones that are, running the events in the background. Once they finish, they end life, and then, they get discarded. So 2 rules to learn about these background threads is that all long-running tasks should be done on a background thread, and the user interface can only be updated from the main thread. So Android forbids code that makes no request or interacts with the database on the main thread. So to interact with the database, developers use a background thread. So this, why, right? Because we cannot have this main thread interacting with a database, and the reason is because the database is it's a big thing, right? It's a whole concept on its own, and we don't want the main thread to be interacting with the database directly, but rather there's a background thread that talks with the database. And so once the background thread queries the database to get some results, such as a list of crime objects, the objects are passed over to the main thread. So after the background thread runs its job, it passes on the information to the main thread. So the main thread is not busy trying to go through the database and query those things. Okay. So then we have something called a coroutine. A coroutine is a solution for defining work that will run asynchronously and is fully supported on Android. And it's based on the idea of functions being able to suspend while so what suspend means is that the function is going to be on pause, right? It's just going to be on hold until it receives the information to continue what it's supposed to be doing. And so when the code running in a coroutine is suspended, the thread that the coroutine was executing on is free to work on other things like drawing your UI, responding to touch events, or making more expensive calculations. So, yeah, these threads are going to be used, or the main thread is going to be used for other things. Okay. So coroutines provide a high-level and safer set of tools to help you build asynchronous code. So under the hood, right, what's happening? Kotlin's coroutines use threads. And it's easy to start work on the main thread, hop over to a background thread, and to perform asynchronous work, and then return the results back to the main thread. Okay, so coroutines, they're pretty much the ones using the background threads that we need to get things done. Okay? So adding dependencies on the build Gradle, we're gonna have to go ahead and add again. I haven't added this, but we will have to add these coroutines inside of those dependencies inside of the build Gradle, TOML file. Do the same way I explained it earlier, but I will have a better demonstration for next week. Okay? But JetBrains, pretty much Kotlin. It's a library that we can go ahead and add these coroutines. So a quick tour of coroutines. To run your code in a coroutine, you use the coroutine builder. And this coroutine builder is a function that creates a new coroutine. So coroutine builder, so right, those are the one that creates the coroutines. So most coroutine builders start executing the code within the coroutine immediately after creating it. And then several builders define this coroutine library. Most of them use so the most commonly used coroutine builders is launch, and that is a function that is defined as an extension class called coroutine scope. So every coroutine builder launches its coroutines inside of the coroutine scope. And so a coroutine scope has control over how the coroutine code executes and includes setting up the coroutine, canceling the coroutine, and choosing which thread will be used to run the code. On Android, the idea of scopes maps neatly into the various cycles. So the activity, fragment, view model classes, they all have unique life cycles and coroutine scopes to match them. So for view models, you can actually access the view model scope class property, and I'm sure we've seen this before. If not, you'll see it soon. But right, it's this. We use this to actually look at or access the class property. And then the view model scope is available from time your view model is initialized, and it cancels any coroutine work still running when the view model is cleared out from memory. All right, so this should explain a little bit more of that code that we see, but we haven't really talked about it, but that's what it does pretty much. Okay. So in here, launching the coroutine. So how do we do that? Well, this is inside of your list view model, calling in the view model type. And then we have a mutable list of, in this case, for us it would be glucose. And then we initialize with a view model scope. Okay. And then the rest should be pretty much straightforward for us. So delaying work. So sometimes we can have, or we want the coroutine, in this case the view model scope, to be able to delay a certain thing. And to do this, we just put in some sleeping. Hold on, let me see. Oh, we're here. We put in a delay of whatever number we need. So in here, for example, we could just say coroutine has been launched, and then I want to go ahead and add a delay. depends on why you want to add delay. For example, you wanted other things or other functions to be running before this one, so you just add a delay and then run for or run whatever you need to. So in here, right, this is the same code pretty much. You have the main thread, you have the log. It says init starting, we launch it, and then we have the log coroutine launched. So then after the coroutine has launched, we want to go ahead and delay it for 5,000 units. In this case, we call it suspension or pause, right? And here we have a draw UI respond to user input. So we allow the user to enter information that we need. And then after the information, and we give it a certain time, right? So it doesn't like pretty much pause, giving you some time to enter the information. And then finally, it goes and loads the stuff. So a little bit more about coroutines. They allow you to perform asynchronous code in resource and perform friendly way. You can define your own suspending functions. Suspending functions can take in parameters, use visibility modifiers, and return values just like a regular functions. The only difference here is that with these suspending functions, you're holding them back, so you're pausing it. Okay, so you could convert one of your regular functions to a suspending function by adding the suspend modifier to the function definition. We've seen this before, I've showed it before, we haven't talked about it, but this is what it means, okay? So making a function as a suspending function limits the number of places where you can invoke it as well. But you need a coroutine scope to invoke a suspending function, and you can call other suspending functions within a suspending function. So in here, we have a suspending function, load crimes. So to be able to load the crimes, here we have the set a value results, and then we add a delay of 5,000. We enter the information, or we query that information and give out the result. So to defining your own suspending function, again, just here pretty much just calling suspend function and then whatever you need. So just like how before there was. Okay. So then we have the fragment lifecycle diagram. We've seen this before, right? So in here we have when there's no fragment at all, non-existent, or it's been destroyed, then it goes into create on start. So once it's created, it runs some functions in the background or some things, tasks in the background to go into on start, and then on resume, right? So you go from here, we don't see these two steps in the middle, but you go from here once you create it to resume. Okay, and this resume is, remember, what you actually are looking at, what you see, the user interfaces, or what the user's interfacing with. And then once we close it, it goes through these steps in the life cycle and then gets destroyed. So calling coroutines from your crime list fragment in this case. And here, again, the list fragment, calling the fragments, what we do is we view the lifecycle, or to use the lifecycle scope, launch it. We use the view lifecycle owner, and then in here we can go ahead and repeat on lifecycle and state started, and then call in the crime list view model to load the crimes, bind using the crime recycler view adapter, and then crimes. Okay. So then moving on, right? So that was coroutines. Remember, anything to get from the coroutines, these are the ones that allow you to pause, do things, determine what routines or what threads to run. Okay, the scope, model scope is same, right? Pretty much the same. All right. So then we have the Room architecture component library. So Room is a Jetpack architecture component library that simplifies database setup and access. So we need to set up a database. How are we going to set up this database? With Room. All right, so it allows you to define your database structures and queries using annotated Kotlin classes. And so it is composed of an API, annotations, and a compiler. So 3 things. The API has classes that you extend to define your database. Then we have annotations such as at entity and at query. Pretty much, just to be able to determine or access them, and you access them and a way to represent them. And then finally, the compiler, which processes the annotated classes and generates the implementations of that database. So again, adding dependencies, I showed you how to do this. Go back to the beginning of the video if you need to go back to this, but pretty much adding the dependencies before you can actually use them. So creating a database, annotating your model class to make it a database entity. And so once you create this class, you will creating the class that it will represent the database itself. So that's the entity. Represents the database itself. So this one, creating a type converter that your database can handle your model data. So in here, entities are model classes you create. So we annotate them with @entity annotation. So model classes. So you know how you have that glucose? You're now going to be doing that @entity to identify it as an entity or pretty much the class for the model. Okay. In room we'll create a database table for any class with that annotation. So automatically we'll create that database table, the table itself. But you need to update crime. You need to update crime to room entity. So how does that look? Well, this is your data class. In this case, it would be our glucose class, right? You have to add this @entity, this annotation, to go ahead and define this as a class. You also have to go ahead and add that primary key. So I'm sure we've all taken a class that you probably know a little bit about databases, at least the basics. That's all you need for this class, right? But in the basics of these, each table needs a primary key, and this primary key has to be unique. And so this primary key in this case would be the UUID. Okay. So creating a database class, first create a new package called database for your database specific code. Right click on the case criminal intent, then includes a new, and then package, and then the name of your package called database, and then create a new class called crime database. I will show you how to do this when we exit this, okay? Or when we get done with the lecture slides. So database package. All right, so from here, again, we are going to call in the entity, or sorry, the annotation database, so that we know that it's there, right? And then we call in version, so glucose, which is a class, entity is equal to, in our case, would be glucose, which is a class, and the version we set it equal to 1. We'll talk about versions later on because we will be modifying these versions as we go into assignment 6. But for right now, know that there is that version 1. Okay, so use that version. Then we're going to have to go ahead and create an abstract class. And I think there's a few slides in the front talking about abstract classes, but we'll be using abstract classes for this database. Okay, but pretty much we have to call in an abstract class and then the name of the database and then there. So now let's talk a little bit about SQLite. SQLite is an open source relational database, and if you know a little bit about databases, relational, it just means that tables are related to each other in some way. Okay. And so SQLite stores this data in simple files, which you can read and write using the SQL library. And each application on Android device has a directory in its sandbox. And the files for an app are stored in this sandbox to protect from being accessed by others. So this sandbox, pretty much, we talked about the sandbox before, but each app has its own sandbox. And in this sandbox, this is where you store the data for that specific app, and nobody else, any other app has access to this sandbox, okay? And so Android includes SQL library as a standard library along with some additional helper classes. But Room also uses SQLite under the hood. So Room serves as an object relational mapping or ORM, library between the Kotlin objects and the database implementation. So Room is able to store primitive types with ease in SQLite database tables, but other types will cause issues. So Room, right? This is a tool that we're using to modify this SQL database. So SQL database running in the background, we don't really see it because we are using Room to interact with it. So so in this case, crime class relies on date and UID objects, which Room doesn't know how to store by default. So we have to use a type converter. So you need to tell room how to convert the types that cannot be stored in default and how to convert from their database representation back to its original types. So to do this, we have to create a class called crime type converters. So again, because we can't go ahead and use all of the types, we have to use a type converter, right? So add one function for data type and add another function for UUID type. So there we go. In this case, it's type converters, right? So we do need one for date for ourselves. Okay, so from date and to date. To do, again, same thing, you're pretty much gonna have to have in your glucose assignment 5, having those type converters, maybe glucose type converters and then date. Pretty much stays the same thing. Okay, going from a long format into a date format, an epoch time. To be able to store these values and be able to pull them out. So in here, you're gonna do an import Android X and then room dot type converters, and then just calling that at type converters class abstract class crime data in this case, and calling the database. And so defining a data access object, the first step to interacting with your database table is to create a data access object or DAO, a data access object, a DAO. Again, so this is, and this DAO is pretty much an interface that contains functions for each database operation that you want to perform. So in this chapter 12, the app's DAO needs 2 query functions. First, to return the list of the crimes in the database. In our case, it would be glucose, right? And then to return a single glucose for us, matching that UUID. So what do we need it for? To be able to access those objects. To be able to access, query the functions, use those functions, okay? So we register a DAO class with the database class. And so with that, we have, again, an import of androidx.room.dao, and then we do an annotation at DAO, and then we use an interface type of, in this case, glucose DAO. And so from here, right, what are we going to add? We're going to add 2 queries things, or 2 query annotations. The first one, select from, and then what table. In this case, it would be our glucose table, and then select all from where, right? So we're going to identify the UUID in this case. And so registering the data access object in the database, we do this by doing an abstract function, crime DAO, and then calling crime DAO. So when the database is created, Room will generate the concrete implementation of the DAO that you can access. So Google recommends the repository pattern to access your database. It's called Jetpack, by the way. It's developer.android.com. Let me fix that now. Jetpack. Docs guide. So in this, a repository encapsulates the logic for accessing the database from a single source or set of resources. It also determines how to fetch and store a particular set of data, and the UI code will request all data from the repository. So in here, what do we have? Well, we have a class called the repository, right? And then this repository has a private constructor. Then we have the companion object, in this case, the instance. Then we initialize the instance, set it equal to null, and then call in the repository, or set it equal to the repository context. Then we get the, when you use a getter, so this get function goes ahead and calls the repository that we need. So then create an application subclass. And here we have a class called, we call the application class, right? So you're gonna have the glucose application class. And in here, we pretty much go ahead and use it to initialize the repository that we have. Okay, so you do need to call this in. So it would be class, for us it would be a glucose application to call in that repository. Now, you have to go ahead and modify your manifest file, Android manifest file, to add an Android name and call it in the criminal, or in this case, the glucose application, dot a glucose application. So then, looking at the repository properties, and here we have the current repository, which is a private constructor. We call in the database, and this database is setting it equal to room to be able to call in the database builder. So room.database builder, we have a context. In this case, we call in the database class.java. Yes, you do have to use that Java because that's really what's running in the background. We use Kotlin as our programming language, but Java is really what's running in the background. And so in here, we call in the database name. So we create from asset, then we call in the database name, and then set up the companion object. All right, so then we have, so building on this, we can add the suspending function. So suspend function to get, the case could be for us to get the glucose, and then we call in the database dot the DAO, and then the getter, and then we can also call the second one, this suspend function. Should be like this. Let me make this, there you go. All right, so then we have these two suspend functions to be able to get the list of glucose in our case and get the glucose by its UUID. So importing pre-populated data. So you can add a database file to the project, use the raw assets to import database to the app as it's our packaging to the application APK file resources, like resources, okay? So I'm gonna show you. Okay. So remember how I mentioned at the beginning of class that there was this database file that you need for your assignment 5? Well, it's this file that you're gonna have to import into your project files to access it, right? So how do we use that? We use the raw assets to import the database to the app and then access our package into the application APK-like resources. So to do this, again, we go in there, we go into import, and then we go into the assets folder. And in this assets folder, we go into main, and then we go ahead and import that in there. Okay. All right, so then pre-populating your database, how do we do that? We have to do this in the repository, right? So in this repository, we just go ahead and do dot create from asset, and then we call in the database, in this case database name, which was a variable declaring that the name of that database. So make sure it does match whatever you decided to call. I think it should be, what did I call it? Let me see. I have it here. Glucose dash database. Okay. And so accessing the repository in the view model, so many components here. So bear with me, there's a lot of things that are connecting, right? I did mention it was going to be a very long lecture. So in here we have a crime list view model, or a list view model. And in there, we are just pretty much going to go ahead and we already talked about the suspending function to load the glucose. We are going to call in the private value of the repository, and then we're going to go ahead and return that repository with the get crimes. Okay, so we have to do the getter. So how to keep criminal list fragments displaying up to date database data. So at this point, the app JBit is set to connect to the user interface. And so the current code is suited to query that database once. And if the parts of the app are trying to update database, then the crime list fragment would be oblivious to changes in percent stale data. So then to fix this, we need to observe the database so that the list fragment automatically receives all the updates to the database regardless of where they come from. Okay. So how we're going to observe this database? Oops. Using flow. Okay, so a flow is a built into the coroutine libraries, and it represents asynchronous streams of data. So throughout its lifetime, it emits a sequence of values over an indefinite period of time, and they get sent to a collector. Okay, and this collector will go ahead and observe this flow, and then be notified every time a new value is submitted into the flow. And so pretty much flows are used to observe these changes. Okay, so flows observe the changes and then go ahead and send those values to the collector. All right, so then we have we need a refactor code to use to flow. So in the crime data access object, we have to make it emit a flow of crimes. And so in the crime repository, or in this case the repository, we have to pass that flow of crimes along. And in the list view model, we have to get rid of the load crimes and instead present that flow of crimes in an efficient way to its consumer. So we're going to go ahead and edit the crime list fragments and collect the crimes from the flow and update that user interface. So then we have a for the DAO, right? The data access object. We have the function in here. We're pretty much gonna call in the getter for the function, and then we're gonna use in the flow of whatever. Instead of using the load, we're gonna substitute with flow. So flow and then the list of the crimes. Okay, and then again call in coroutines flow.flow. As long as you import the coroutines, call it next, that should be more than enough. So then we have, so for the repository, again, we have to use the getter function get crimes. In this case, we have to use the flow and then call in the database. So we're just replacing that load with flow. Okay, and then clearing the slate. So to clear the slate, in this case, we can go ahead and look into the list view model. And then let's see, we go ahead and knit the view model scope launch. We have these from before. So accessing values within the flow. How do we access values within this flow, such as the crimes? Well, we can observe the flow using the collect function, and the collect function, or the collector is a suspending function. And you can call it within the coroutine scope. You can also call it with in the crime list fragment, and on view create callback, since you already set it up in the coroutine scope there. So in here, again, we have the list fragment, and then in the view lifecycle owner, we go in the lifecycle scope.launch, and then from here we call in the collector, so .collect. Okay. So then we have the state flow, and this is a special version of flow that is designed specifically to share application state. It always has a value that observes and can collect from its stream, and it starts with initial value and cache the latest value that was submitted into the stream, and it's the perfect companion for the view model class. It provides fragments and activities as they get recreated. Okay, all right, so then, so how do we create a state flow? We create an instance of a mutable state flow, and this is a read-only flow, while a mutable state flow allows you to update the value within the stream. And when creating, so when we create this mutable state flow, we need to provide an initial value, and the initial value is what the collectors receive before any of the other value can be put in the stream. So using the view model scope in the init block, the crime list view model can collect values from the crime repository. And once you have that value from the database, Flow can set up the value in your mutable state flow. But how do we protect access to the stream? So in here, again, this is the state flow, right? So mutable flow is initially an empty list. So you have the state flow, which is the crime, and then in here we use that as state flow. So now that we run the app, it should have the list of the data. So this is loading from that database file. Okay, all right. So then, did mention. Let me see. So we have to talk about the asset. I'm going to show you how to do that. And there was another one that I wanted to show you. Let me just go for God before I forget. A dependency. Give me a second here. Yeah, I'm not sure what was the other one. I forgot about it. Okay. Anyways, but how do we do this, right? So it's going to be here in your resource file. So as you can see here, right? Sorry, it's not your resource. It's your assets folder. Okay. So you're going to go ahead in here, and then you're going to go new. Oh, I remember. Okay. It was a package. So we are going to call the Android a resource directory for the one that we need right now for the assets. Okay, so to call in that data, the database. So we're gonna find here, and there should be an assets. Yeah, yes. All right, and then in this assets, let's see what. Should be the main assets. Yeah, just normal, I guess. Should be the main. Okay. And then we just created. Oh, it's not a valid resource directory name. Okay, let me do that again. Oh, I was in the wrong place. Okay. No, I was in the right place. Okay, so in here, it's in the app. So new Android resource directory, and we're gonna call it assets. Okay, I see. What am I doing wrong? New. Oh, it's a directory. Assets. Is it there? No, it's not already there. Okay, so it's a source main assets. So it should be this one. There we go. And that's all you need. All right, so in here, you can go ahead and import. So let's see. New should be an import. All right. What you can also go ahead and do is open it through like the file explorer if you're using Windows, or files if you're using Mac or whatever you need, and then just dump it in here. Okay, so maybe there's a file. Oh, no, export. I want to import. Okay, it's okay. I could probably just drag it here, but that's where you would add your database file. Okay, and the other thing, right? So that's the other thing I forgot to talk about, or I was supposed to do it, right? So I'm going to go ahead and create a new, and I'm going to create a package. And this package is the one that we need to hold our database information. Okay, so that's how you would create the new package. So in here, for example, we created a placeholder for me. So I'm going to call it package, and then I'm going to put database. So I have my database folder here. And then in here, I'm going to go ahead and input it, like, for example, my glucose. My glucose should be in there. Actually, I'm not going to refactor it. But in here, you would have your DAO files. You'd have your repository, things like that. You would put it in here for your database. Okay, so assets is for your actual database file, and database package would be for your database applications that you need. Okay, all right, so I'm going to go ahead and stop the share. Oops, and I didn't realize I had my camera off. So that's it. I did go a little bit over time, but hopefully this helps you. If you have any questions, please send me an email. And yeah, we'll see you next week. Have fun.